learn how to it, but we're live on YouTube. Um, can you maybe
Oh, okay.
start
So, okay. Like from the slide or with the presentation?
No, the presentation, the hands-on, yeah.
Okay. So, good afternoon, everyone. Welcome to Ethereum Nigeria South Tour workshop. Today is Ethereum Portharcourt South Tour, and we've been talking on zero knowledge. And zero knowledge, just to reiterate, is a concept in cryptography that allows for one person to prove to another person that they have knowledge of something without revealing this information, the value of what they have. So earlier we're looking at a hands-on, and to implement a successful zero knowledge proof, we normally have four phases. We have the setup phase, the initialization phase, the proving phase, and the verification phase. Now, at the setup phase, the prover, which is the person that claims to possess this information, makes a statement, an assertion to a verifier who is going to verify this information that he or she possesses a certain information. It could be an NFT, it could be a certification, it could be a user data, any kind of information, sensitive information that the prover doesn't want to reveal, but wants to prove to the verifier that they actually possess this information. So at the setup phase, the prover comes up with the statement that they possess this information, and the verifier acknowledges this statement, and this statement is being committed. So after the setup phase, we have the initialization phase. At this initialization phase, after committing the statement that the prover made, or the assertion that the prover claimed to have, the verifier now sends a challenge, right? So looking at what we have on my screen here, you can see here our secret is, we're just saying this is our secret, right? Our secret is very secret. So we're saying that our secret is our secret that we don't want to reveal. So this is the secret that the prover claims to have. Now, this secret could be, like I mentioned earlier, it could be an NFT, it could be some amounts of tokens, it could be certifications, it could be anything on the blockchain, any information that the prover possesses in their wallet address, right? So the prover now says, we are saying that this is our secret, that's the information we want to prove we have without actually revealing it. So in the setup phase, after that, of course, we committed this information. This commitment is done between the prover and the verifier, but the prover doesn't actually reveal their information, right? They just commit that they claim to have this information. Now, the next phase here is the initialization phase, where the verifier now sends a challenge. Usually, this challenge in real world, in real application, is often high advanced cryptographic technique, right? Algorithms. So this challenge is public to both the verifier and the prover, right? So once the verifier sends this challenge to the prover is going to use this challenge to verify that they possess this information. So we'll just see how it works in a bit. So the challenge, we're assuming here that we're sending a challenge of number one back to the verifier, to the prover, sorry, that that is our knowledge, that is our challenge based on the knowledge of the secret they claim to have. Now, in this example, this information they claim to have, of course, is the secret, which could be anything, right? So we're saying that based on this, your information, based on your secret, I'm sending you a challenge, and I'm sending you one as a challenge, right? So we're at the proving stage where I mentioned that we're now going to use this challenge to actually prove if we possess this information. So we're saying that if the challenge is equals to one, which of course is one, it should first, we're just acknowledging that the challenge is valid. Then we're now going to send a response, right? Not our secret this time, we're sending a response, and we're going to say that the response is our secret, right? So if the challenge is not valid, okay, let's just add an else statement so that we can verify something. So if the challenge is not valid, let's print challenge is not valid, right? Let's just print that out, that the challenge is not valid. Now, remember, at this point, we are not sharing our secret. We are just saying that if the challenge is one, then the response is equals to our secret. The verifier does not actually know this secret, right? We are just saying that if the challenge that the verifier sent to us is actually the challenge, right? Then the response we are sending to the verifier is our secret, but not actually revealing the secret, right? So at this point, this is where we are verifying that we actually have possession, or we actually possess what we claim to have. So the next phase, of course, after the proving phase, the last phase is the verification phase. Now, this is where the prover uses the response sent by the verifier, uses the response sent by the prover to actually verify if they actually possess this information. So the last phase is the verification phase. And we say that, let's use an if statement, right? Let's say that, okay, let's say verification, right, is equals to, we are still going to use hash sleep. Remember, we are receiving the secret, but during our commitment, right, we had to actually hash it because it is best practice to always hash strings. excuse me. It is best practice to actually hash strings on the blockchain, right? Especially sensitive information. You don't want to leave it out there because the blockchain, if your protocol has a breach, and you did not actually hash any of your strings, it will be visible to everybody. So what we did here, of course, was just to hash it to make sure we have a hexadecimal that we can compare with, right? So in the same way, we are going to still hash. Hash our response, the response we are getting from the prover. Excuse me. So just like we did, we say here we are getting the response, and then we are going to encode this response, just like we encoded the commitment, then X digest it, right? So just like we did during the commitment, because we are going to be comparing this response against the commitment, right? So just like we hash the secret to get when we're committing it, so also we are hashing the response when we are verifying it, right? So and then we can now then say that if the verification is the same thing as the commitment, right? So if it's the same thing as what we earlier committed, let's just have a print statement. Let's say user credential is valid, right? So let's just print that the user credential is valid, and if it's not valid, let's print maybe user credential is invalid. User credentials, right? So okay. So basically, like I mentioned, this is just a simple implementation of zero knowledge, how it actually works, right? So we of course had our setup phase, then we initialized the challenge, we proved the challenge, and then we verified the response from the challenge against what we committed earlier. So if we should run this right now, I'll just save this. If we should run this right now, I think I need to make this bigger. Appearance. Okay, I think this is fine. Yeah, so I will run this. Let's run our code. Let's see. So now our challenge, of course, let me try to make this a bit bigger. Appearance. Yeah. Okay. So as you can see here, our challenge is valid, of course, because it is valid, and our credential is saying that the user possesses this information, right? The user credential is valid. So basically, let's try to manipulate it a bit, right? Let's say after telling or after asserting that we possess this secret, let's just have a fake secret, right? Let's say a fake secret, and let's call our fake secret a fake secret, right? So let's call our fake secret a fake secret. Now remember, when the prover actually made the statement, what we agreed on was that he knows what something called secret, right? He has information on something called secret, or he possesses something called secret. Now, that is actually what we committed, that information, that secret, right? So let's say we have a prover that tries to manipulate the system, right? Try to send us false information or doctored information. So let's just try that. And at this point, instead of sending the real secret, right, as the response, it decides to send us another information, trying to beat the system. So at this point, okay, let's run the code one more time. Let's see what happens. Let's see. So now you see that our challenge is still valid, right? But then we are having an invalid user credential because that was not what we agreed. That was not what we've committed, right? Somebody is trying to beat the system, right? So this is just a way for the simple implementation of how zero knowledge works. Of course, it is advised in real life to always you can repeat this process multiple times just to ensure that the user actually possesses this information. So instead of sending our fake secret, let's send our secret and let's change the challenge, right? Now we change the challenge to 2. Of course, this challenge is public knowledge. Remember, we've tried 1. So we now tell the prover, use 2 as your challenge, and the prover uses 2 as his challenge. Then let's run the code one more time. Let's see if we have a valid user. Yeah, our challenge is valid and our user is valid, right? So, but what happens if the challenge is not valid? Let's see. Let's change the challenge to 4 or something. Save it. Then let's try again. Yeah, challenge is valid, but response is not defined. I think we have response equals to secret. Okay, we're having the error because we are committing our secrets. Yep, and response is not defined. Why? Response. Let's see. Challenge is not valid. I just want to see what caused the name response, name error. Response.encode. Response is not defined. How come? This is response. This is response. Oh, I think I have. No, it's not the type here. Okay, so everything works just fine. Let's change the challenge. I want us to have an invalid challenge. Let's see what happens. So we have an invalid challenge. So yeah, we did not make provisions for this. Yeah, I see. Okay, but basically this is just the general idea of how zero knowledge works. So we can actually prove to someone that we actually possess information about something without revealing this information to that person. So we can do this multiple times to ensure that the accuracy of what we are getting back is actually the more accurate, the more positive or valid response we get, the more accurate we know that truly this prover actually possess this information. Because if they do not possess this information, like we saw in the case of the fake secret, it will always return an invalid credential response. So gift, that is that from me. I don't know if I have questions or I have comments. I'm still waiting. So over to you, Gift. That's that from me.
Wow. A very much round of applause. I said, like, you spoke a lot. I really gained a lot. I don't know for another person, but for me, I am really amazed. Thank you once again for sharing your knowledge. So I think we have like 2 minutes left for this call. So if anybody has any questions from the audience or a comment, so Mr. Enoch, Mr. Simon, does any of you have like a comment or a question for us? Let's start it before we close. Okay, no, seems like we don't have any comments nor questions. So
Okay.
So I would like to thank you, Mr. Etetek, for coming up. It was really wonderful having you. I really appreciate you, and we hope that we can help grow the Ethereum Nigeria community in Portharcourt. And when next we speak better. So this is me appreciating you once more. It was an awesome time having you. So already this workshop is broadcasted on our YouTube channel. So if you have anybody that wants to learn more, anybody that has a question on Zero Slacks, I want to learn from you, you can also forward it to them and another person in the audience. So thank you very much, Mr. Ketek. So thank you, our participants, Mr. Simon, Mr. Enoch. We appreciate you. So thank you very much. This is me from Portharcourt. Okay.
All right. Thank you, everyone. Thank you, Gift. Thank you, everyone. It's a pleasure to be here. And I know that subsequently, please don't forget to subscribe to Ethereum Nigeria, our YouTube channel. You can follow us on LinkedIn, Ethereum Nigeria, X, formerly Twitter, Ethereum Nigeria, of course, Facebook also, Ethereum Nigeria. Thank you very much.
Thank you. That's me from Ethereum Nigeria, Portharcourt. Thank you very much. Have a nice time.